In this video, we will talk about the quadratic formula. Now, we actually brought up the necessity of the quadratic formula in the previous lesson. So in the previous lesson, we're talking about solving quadratic equations by factoring, but by the last example, we did one where we couldn't factor. We couldn't factor because there's some expressions we learned that are not factorable over the rational numbers, okay? And if that's the case, then we really can't progress. We can't break it down to the factors and apply the zero product property. And if that's the case, then we have our superhero coming to our rescue. We have this thing called the quadratic formula. Now, I really want to emphasize, please don't use the quadratic formula if you can solve by factoring, because you know what, I won't explain why, but I'll just highlight the point right now. If you can factor, please solve by factoring. There's really no need to solve the quadratic formula. You really want to just use the quadratic formula when it's like your last resort. Okay, so do not worry if you see these expressions where you can't factor, because we have the quadratic formula. Okay, it's going to come to our rescue, and you can solve those equations. So let's derive the quadratic formula together. So we're going to start off with ax squared plus bx plus c equals 0. So what we're going to do is essentially complete the square. Okay, so if you go back to completing the square handout, a lot of the steps that I'm going to write here are very similar. In fact, I really want to jump to that last line, but you know what? I'll show my steps again. I'll factor a from the first two terms, just like what I would do for completing the square. And then I'm going to complete the square. So you take b over a and divide it by 2. So you get b over 2a and square. So this is our perfect square trinomial. Okay, but if I add by that term, I also have to subtract by that term. Okay, so far so good. That fourth term, I really want that guy out of there because I want my perfect square trinomial. Oops. So this would be b squared over 4a squared. But b squared over 4a squared times a would be b squared over 4a. Okay, I'm going to clean this term up. I'm going to simplify that. I need a common denominator. So this might be trippy, but you want to the lowest common denominator here is 4a, so this should be 4ac in the numerator. And you know what? This is a perfect square trinomial. Let's write it as x plus b over 2a all squared. Okay, so after this step, you should really pause, okay? Because if you have it in essentially vertex form, what you can do, okay, is rearrange. You can rearrange and then you'll eventually be able to isolate for x, okay? If you have, I don't want to say it this way, but if you have an x squared term and an x term, you can't isolate for x. But if you have it like this, like I said, vertex form, very similar to vertex form, then yeah, you can rearrange and isolate for x. So I'm going to add both sides by b squared plus 4ac over 4a. And then divide both sides by 4a. Sorry, divide both sides by a. So this would be 4a squared in the denominator. And now you're going to square root both sides. Now be careful, when you square root both sides, now it's going to be plus or minus. I'll talk about why it makes sense to do plus or minus here, but let's just write that down first. We'll do some examples with real numbers, so it'll be very clear why it makes sense to be plus minus. And then let's isolate a. Okay. Now, if you look at this radical, if you look at the square root, the denominator is 4a squared. That's a perfect square. So actually you can simplify that to be 2a, right? Because square root of 4a squared is just 2a. So guess what? Common denominator, you can simplify one last step. So again, negative b plus or minus b squared plus 4ac all over 2a. Bam! That is it. That is the quadratic formula. Okay? The quadratic formula enables you to avoid all these steps. Okay? You don't have to do these steps every single time you encounter a quadratic equation which you cannot solve by factoring. It bypasses all these steps and bam, jumps to the last line, and then you just crunch it out, and once you figure out a, b, and c, just use your calculator. Okay, so there's actually 3 ways to solve it. Okay, a quadratic equation. You can solve by factoring if you can solve if it's factorable over the rational numbers. Now if it's not, you can actually do another technique which is called completing the square. So I'll show you. You can actually solve this by completing the square. X squared minus 4x. The perfect square, so divide this by 2 and then square would be plus 4. But if you add by 4, you have to subtract by 4, and don't forget about the negative 9. Okay, so this would be, this is x minus 2 all squared. And this is minus 13, of course. Guess what? You can now isolate for x. Just perform inverse operations, right? Just rearrange and isolate like you did in grade 9. So x minus 2 squared equals 13. Now hold on here. Now why is this plus or minus? Now think about it, okay? X minus 2. If I square whatever x minus 2 is, I get 13. Well, think about it. X minus 2 could be positive root 13 or negative root 13. Okay, now if that's confusing to you, think about it. If x squared equals 4, okay, the most logical thing you're going to say to yourself is x is equal to 2, because 2 squared is 4. But wait a minute, negative 2 squared, if I square negative 2, that's also 4, right? So that's why when you square root, you have to be plus or minus. All right. So this is very different from saying, what is the square root of 4? Because students confuse that, okay? Me asking what the square root of 4 is very different from me saying, hey, let's square root both sides of an equation. So please don't get that confused. If I ask you what's the square root of 4, don't say plus or minus 2. The square root of 4 is just 2. But if I say if x squared equals 4, then yes, x is equal to plus or minus 2. For whatever reason, this really trips the students up, so take your time and think about that, okay? So the only reason I brought this up is because when I square root both sides of my equation, it's going to be plus or minus root 13. And then of course, finish it off by isolating x. So this is called solving a quadratic equation by completing the square. But you see all these steps? All these steps? You could have bypassed that. You could have bypassed that because well, later on maybe, you will memorize the quadratic formula, right? So this is one way of doing it. This is solving by completing the square. And which I really feel like you don't need to know that method, because that's basically what the quadratic formula is. The quadratic formula allows you to avoid all this algebra. All right, so you know what? Let's bust out the quadratic formula this time, and then I'm going to solve it using a quadratic formula. So A, B, C, not that you need to write it down, I just write it down for you because this is the first time you're using the quadratic formula. So x is equal to, you know what? I'm also even going to write the formula down for you. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, let's sub, and then magic will happen. Okay. This is 16 plus 36, which is 52. Be careful of the signs. A lot of students struggle with the signs here. So negative 4 times negative 9 is positive 36. And of course, negative 4, if you square negative 4, that's going to be positive 16. And there you go. Now I know, you're like, wait a minute. The quadratic formula and the other method of completing the square gives you different answers. I know they look different, but they're actually the same. Now in grade 10, we don't teach you how to simplify radicals, but I assure you they are the same. So, you know what? Let's check it out. So 2 plus root 13, 5.6, okay, let's say. Now here, this is a good practice for you to calculate this. So this is 4 plus root 52. You need the brackets because it's all of 4 plus root 52 over 2. Bam, 5.6 about. Okay, I assure you they are numerically equivalent. And then, of course, 4 minus root 52, bam, negative 1.6-ish. So 2 minus root 13, bam, exact same answer. Okay, so usually when we ask for the roots, the solutions to the equations, I personally love exact answers. I don't want decimals, so yeah, just leave them the way they are right now. But if they ask you to round to 2 decimal places, then so be it. Okay, so just check with the homework. Some of them ask you round, some of them ask for exact roots. All right. So I really feel, sorry, I'm just going to quickly say one more thing. So this method of completing the square, I really feel like you don't need to do it if you know the quadratic formula, because the quadratic formula allows you to bypass all these steps and just punch it into this fancy formula to get you the answer. But you know what? If you ever forget the formula, you know what? Just solve it by completing the square. You don't need to memorize the formula. If you forget, you forget. So be it. Okay? So there's always a backup plan. Okay, so let's practice our skill of using the quadratic formula and solving for the roots. Okay, so always set it equals 0, right? Because otherwise you can't use a quadratic formula. Okay, so x equals negative b plus or minus square root b squared minus 4ac all over 2a. I'm only writing the formula then because this is, I really wanted to sink into your head, so have it memorized. So plus or minus the square root, so it's negative 4 squared minus 4ac all over 2a. Okay, so it's 4 plus or minus, this is 16, this is 8 times 9, 72. 72 plus 16, let me just triple check, yep. Bam, 88. You can simplify this. Some calculators actually allow you to, like, they simplify for you and they give you a prettier answer. It's like reducing a fraction. Some calculators will reduce it for you, but since we don't learn this skilling, you learn this in grade 11. You learn how to simplify in grade 11, so I'm okay. I'm very accepting of this solution. All right, let's do another one. All right, x squared. Let's write it down a few more times. Hopefully you can memorize it by the end of this lesson. And if you want, you can write what a, b, and c is. So 4 times 3 is 12. 12 times 7 is 84. 84. Ooh, I just noticed something. 1 minus 84, negative 83. Okay, so we're going to talk about this in the next lesson as well. But these are the roots, okay? Now, in high school math, we see the square root of a negative value, and we basically say that the solutions the solutions for this equation are not real numbers, okay? Now they are numbers, they're just not real numbers, and we don't work with these types of numbers in high school math, but in university you may encounter them, okay? So if you see them, you basically say these are the roots, but they're not real roots. Okay, they're not real numbers. Now, if they explicitly say like solve for exact roots, where let's say if they add this little statement here, x is a real number, then you say no real roots, or no real roots would be a perfect thing to say. Okay, now since this wasn't there, you know what? I'm just gonna leave it like that. Okay, there's nothing wrong with those roots, but they're just not real numbers. Now, if you get a word problem and you get these kind of roots, then you say, you know what, just reject them. They're not meaningful with respect to the word problem that you're trying to work with. Okay. All right. Set this equal to 0, and then you bust out the quadratic formula. Oops, negative 1. So I'm just gonna push it right in. 4AC. 4 times 12 is 48. 48 plus 49. Ooh. So this is why I say what I said earlier. So once I saw 49, I saw that here under the b squared minus 4ac, when I evaluate that, it's 49. 49 is a perfect square. And once I see a perfect square under the radical, I punch myself, because I think, oh, that's so silly. Why would I use the quadratic formula? Once I see a perfect square, you know what that means? It means it was factorable. So 1 plus 7 over 2 and 1 minus 7 over 2. So 1 plus 7 is 8. 8 over 2 is, of course, 4. Or 1 minus 7 is negative 6. Negative 6 over 2 is negative 3. Well, that was silly. Why would I use a quadratic formula? So I'll do a side by side. Okay, so once you're at that step, always ask yourself, is it factorable? Because if it is, why go through all that trouble of using this giant formula, right? You don't need it. You don't need it if it's factorable. Just resort to just use your factoring techniques. Now, saying that, some students, they really struggle with factoring, so they just use a quadratic formula for every single question on the test. But if the question states you have to solve by factoring, then you gotta use your factoring techniques. Okay. Now, I guess you could cheat a little. You can just use the quadratic formula on a scrap piece of paper and then reverse engineer the factors, but that's time consuming. Okay, so let's just be practical and just improve your factoring techniques, because you'll need that skill in grade 11 and 12 anyways. Okay, so this is really good. Okay, so we got some examples where you do need the quadratic formula, like 2a. And then there's some, be careful, because you can use the quadratic formula and you end up with roots which are not real. The roots are not real numbers. So these are actually called complex numbers, okay? We won't encounter and work with them very often, but just understand, if you do get roots which are complex, they are beautiful numbers, okay? They are called complex numbers. It's just that we unfortunately don't work with them in high school math. Now in C, I'm trying to say, I did this example because if I really want to highlight if it is factorable, why are we using the quadratic formula, right? All right, so just go over example 2. That was really good combination of things. All right, last one. You have this equation, represents how high above the ground it is after t seconds. How long does it take for the ball to reach the ground? So let h equal 0. So negative 5t squared plus 7t plus 3. Is this factorable? I'm playing with the factors in my head. No. So if that's the case, use a quadratic formula. Now this time I'm actually going to round it to 2 decimal places. Okay? So you punch this with a plus and then all over negative 10, and then with a minus and then negative 10. So this is how I would do it. So negative 7 plus, be careful, square root all of that. and then divide by negative 10. So you get negative 0.34. Let's do 2 decimal places. And then let's do negative 7 minus the square root of 7 squared minus 4, negative 5, 3, close the bracket. So square all that and divide by negative 10. And it's about 1.74 seconds. Okay, let me just triple check that real quick. Beautiful. All right. So how long does it take the ball to reach the ground? So this answer makes no sense. How can it hit the ground? How can it hit the ground before we even threw the ball? So we reject it because t is greater than or equal to 0. Okay, this makes no sense. How can I say it hit the ball before I threw it? That's some magic. So therefore, the ball hit the ground approximately after approximately 1.74 seconds. Okay, on the test we'll tell you whether we want exact roots or we want approximate roots. Okay, and we'll tell you, of course, round it to 2 decimal places or whatever. Anyways, there we go. So now you have the ability to solve all the quadratic equations you want. If it's not factorable, use a quadratic formula. Forget the quadratic formula, no problem. Complete the square.